Picture a crisp night in July 2025. The Atacama Desert of Chile shimmering under a sky so clear the stars seem to pulse like living things. In a quiet observatory, the Asteroid Terrestrial Impact Last Alert System, ATLAS, sweeps the heavens, its mechanical eye scanning for cosmic wanderers that might one day threaten our fragile planet. On July 1st, at precisely 4:15 a.m. local time, it locks onto something extraordinary, a faint spark slicing through the constellation of Libra, glowing at magnitude 17, hurtling at 134,000 miles per hour from the outer reaches of our solar system. At first, it's just a data point, a blip on a screen filled with countless others. But as pre-discovery images pour in from archives dating back to June 14th, astronomers realize they've stumbled upon something far more profound. This isn't a local asteroid or a familiar comet looping back to the sun. This is 3I/ATLAS, the third confirmed interstellar object to grace our cosmic neighborhood, a visitor from beyond the sun's gravitational reach, carrying secrets from a realm we can barely fathom. Step into that control room, where the air hums with the low buzz of electronics and the faint bitterness of instant coffee. The room falls silent as screens light up with the object's trajectory, a hyperbolic orbit with an eccentricity of 6.141, a near straight line through space that screams outsider. Unlike Halley's Comet, which returns like a faithful friend, or asteroids dutifully orbiting the sun, 3I/ATLAS is on a one-way journey. It's slingshotting past Jupiter, grazing Mars on October 3rd, dipping to its closest solar approach, perihelion, on October 29th at 1.36 astronomical units, about 203 million kilometers, then vanishing into the cosmic dark after a close encounter with Jupiter in March 2026. Its speed is a blistering 60 kilometers per second relative to the sun, faster than any probe humanity has ever launched. And its origin, traced back through orbital models, it likely hails from the Milky Way's thick disk, a region populated by ancient stars, making it 7 to 14 billion years old, a relic from the universe's wild formative years, older than our own solar system's 4.6 billion year history. This is where the story hooks you, pulls you in like the relentless tug of gravity itself. 3I/ATLAS isn't content to be a silent rock tumbling through the void. It's alive with activity, glowing, shifting, and whispering secrets in a language of emerald light and anomalous trails. Its coma, a hazy shroud of gas and dust, swells to 2.5 arc minutes across, a ghostly veil that has turned heads from the observatories of Mauna Kea to the pristine dark skies of Namibia. During the September 7th blood moon lunar eclipse, when Earth's shadow plunged the night into perfect darkness, amateur astrophotographers Gerald Riemann and Michael Yeager, peering through a 12-inch astrograph, captured a breathtaking sight, a verdant specter glowing against the black, leaping from magnitude 14 to 12 in mere weeks, far brighter than any model predicted. That green glow isn't just a pretty picture, it's a clue, a cosmic breadcrumb leading to deeper mysteries. In the lore of comets, emerald hues come from dicarbon, C2, a molecule of two carbon atoms dancing in the sun's radiation, fluorescing like fireflies in the visible spectrum. But early spectra from the James Webb Space Telescope, taken on August 6th, showed scant C2, no abundance to explain the vivid glow. Instead, 3I/ATLAS is exhaling carbon dioxide at a staggering 8 times the rate of water vapor, a CO2/H2O ratio near 8, a chemical cocktail unheard of in our solar system's icy wanderers. Water should dominate at these distances, sublimating under the sun's gentle warmth. But here, CO2 jets erupt at 3.5 astronomical units, where temperatures hover at a frigid minus 200 degrees Celsius, far too cold for easy vaporization. It's as if the object is thawing from within, its chemistry unfolding like a carefully timed release. Its glow steady and consistent, not the chaotic flicker of natural outgassing. Some astronomers whisper of active regulation, a controlled burn, not a passive melt, as if 3I/ATLAS is orchestrating its own transformation. Now let's shift gears, diving into the physics that defies everything we know. Comets follow ironclad rules. Solar wind and radiation pressure sculpt their tails away from the sun, pointing anti-solar, no exceptions. Halley's Comet 2I/Borisov all obey this celestial law, their tails streaming outward like hair caught in a gale. But on August 27th, the Gemini South Observatory in Chile captured something that shattered this paradigm. A cigar-shaped extension, 10 times longer than wide, stretching toward the sun, an anti-tail defying the 400 kilometers per second onslaught of solar wind. This isn't a fuzzy, chaotic smear that might result from random processes. It's a geometric marvel holding its precise form as 3I/ATLAS orbits retrograde, backward against the flow of our planets. Hubble's July 21st image, taken at 277 million miles, revealed a teardrop cocoon of dust leading the nucleus, asymmetric and forward-leaning, as if the object is pushing against the solar tide. Professional telescopes like Webb and Hubble have struggled since August, their views washed out by solar glare, leaving dedicated amateurs as humanity's primary eyes on this enigma. The data is unyielding. No natural force explains matter streaming sunward. Solar wind pushes outward. Radiation pressure shoves away. To counter that, you'd need electromagnetic fields, propulsion jets, or solar sails channeling light against the grain. Technologies we dream of in science fiction, not phenomena we expect from rocks. Harvard's Avi Loeb, a trailblazer in astrophysics, calls this anti-tail a major anomaly, one of 5 red flags stacking like cosmic dominoes. In his September 25th Medium post, he muses, if this is natural, it challenges everything we know. If artificial, we're not alone. Feel the awe, the chill down your spine as the scale of 3I/ATLAS sinks in. This isn't a pebble skipping through space. Astrometry from 4,000 measurements across 227 observatories pegs its nucleus at over 5 kilometers wide with a mass exceeding 33 billion tons. That's the size of Manhattan, dwarfing Oumuamua's 100-meter cigar and 2I/Borisov's 1-kilometer core by orders of magnitude. Hubble's August 20th observations set an upper limit of 5.6 kilometers. But here's the kicker. Despite JWST measured outgassing at 150 kilograms per second, jets that should nudge the orbit like a rocket's thrusters, there's no deviation. The path remains purely gravitational, with non-gravitational acceleration under 15 meters per day squared. For a comet shedding mass, that's impossible without immense inertia, as if the core is armored, unyielding after eons of cosmic rays and gravitational tugs. Imagine its journey, a billion-year odyssey through the galaxy's hostile voids, dodging stellar encounters, bathing in relentless radiation. Natural objects that large should shatter erode into gravel under cosmic bombardment. Yet 3I/ATLAS arrives intact, its infrared emissions, analyzed via the Very Large Telescope, hinting at complex thermal gradients, uneven heating across a vast surface. Loeb's team calculates, at solid density, it's a fortress, potentially housing propulsion, navigation, or communication systems. The anti-tail, precise orbit, and selective chemistry could all be manifestations of technologies operating within this colossal framework, a structure that challenges our understanding of what's possible in the cosmos. The chemistry of 3I/ATLAS tells a story that doesn't fit any natural process in our catalogs. Spectroscopy from the Very Large Telescope reveals nickel vapor, atomic and abundant, but iron barely a trace. In stellar forges, supernovae, fusion cores, iron and nickel bind in predictable ratios, etched into every asteroid and comet across the galaxy. Here, nickel dominates, a signature of industrial alloys, purified for engines or hulls we might build on Earth. Add to that cyanide plumes and a CO2 heavy breath, water a mere trickle at 6.5 AU, where dust activity sparked far beyond sublimation range. Volatiles locked deep, thawing on cue, suggest controlled processes, not passive heating. And the green glow, if not C2, what is it? Exotic molecular mixes or engineered phosphors? It's a chemical fingerprint of manufacture, not geology, a composition that screams made rather than born. The intrigue deepens with the behavior of light itself. From September 7th to 15th, 3I/ATLAS surged in brightness, defying the inverse square law that governs celestial objects. Models predicted a steady dimming with a light curve of R to the power of negative 3.9 early, flattening to RR to the power of negative 1.2. But this leap suggests internal systems flickering on after crossing 2 AU. Polarization adds another layer, extreme negative at minus 2.6 0.7% for small phase angles, a deep branch unseen in natural dust. Comets glow positive, asteroids neutral. This inversion points to metallic or synthetic grains, perhaps engineered surfaces bending light in defiance. Hubble's forward glow on July 21st hints at emissions, radio whispers below detection, and during September's coronal mass ejection, when normal comets shred tails and sputter cores, 3I/ATLAS held steady, its anti-tail unshaken, a testament to an almost unnatural resilience. Time is running out and the stakes couldn't be higher. On October 3rd, 3I/ATLAS will pass within 29 million kilometers of Mars, offering humanity's final clear shot at unraveling its mysteries before it plunges toward the sun. This isn't just another observation window, it's a meticulously coordinated scientific campaign, a cosmic heist leveraging some of the most advanced instruments ever sent to another world. NASA's Mars Reconnaissance Orbiter, MRO, will deploy its high RISE camera, capable of resolving desk-sized features on Martian dunes, now trained on 3I/ATLAS at a pixel scale of 30 kilometers. Will it reveal craggy ice sculpted by eons or geometric facets hinting at artificial construction? The European Space Agency's Mars Express will contribute high-resolution imaging and spectroscopy, sniffing for exotic gases. India's Mangalyaan, with its ultraviolet scanners, joins the effort, while the ExoMars Trace Gas Orbiter hunts for trace molecules that might betray a non-natural origin. China's Tianwen-1 orbiter aligns its instruments, adding another layer of scrutiny. Mission controllers must plan observation sequences days in advance, calculating 3I/ATLAS's precise position as it hurtles through space. The stakes are monumental. If high-resolution images show a kilometer-sized nucleus shedding mass like familiar comets, a natural explanation might hold despite the anomalies. But if the surface glints with artificial electromagnetic signals, maintains structural integrity unlike any natural comet, or reveals geometric features inconsistent with random geological processes, the technological hypothesis will gain overwhelming support. The orbit of 3I/ATLAS reads like a carefully planned reconnaissance mission, not the random tumble of a natural object. Its path aligns within 5 degrees of the ecliptic, our planetary plane, where all our planets orbit, a statistical improbability for an interstellar interloper approaching from the vast three-dimensional void of space. The odds of such alignment are less than 1%, akin to throwing a dart from a galaxy away and hitting a bullseye the size of a dime. Retrograde, moving backward against the planetary flow, it chains precise flybys. Mars on October 3rd at 29 million kilometers, Venus in December, and Jupiter at 54 million kilometers in March 2026. This isn't a haphazard trajectory, but a sequence that maximizes observation of our solar system's key worlds. Avi Loeb, in his September 25th paper with collaborators Chloe and Veras, emphasizes the improbability. This alignment pattern mirrors what you'd expect from an artificial probe designed to survey a star system. He writes, a reconnaissance mission would naturally aim to pass close to major planets, and 3I/ATLAS's retrograde orbit allows it to encounter them as they move in their normal paths, extending observation windows. The timing is equally uncanny. Had it arrived months earlier or later, it would have missed these alignments entirely. A velocity change of just 30 to 40 kilometers per second in October, well within human rocket capabilities, could arc it earthward by December 26th to January 9th, 2026. NASA assures no threat. Its closest approach is 1.8 astronomical units, 170 million miles. But the what-ifs linger. Could it shed mini drones at perihelion, hidden by solar glare, or function as a von Neumann probe, a self-replicating machine seeding the stars? Loeb's Loeb scale rates it a 4 out of 10, halfway to artificial, with anomalies piling like storm clouds, daring us to look closer. The precision of this orbit forces us to confront uncomfortable questions. Interstellar space is a three-dimensional lottery. Objects can approach from any direction with equal probability, yet 3I/ATLAS threads the needle, arriving along a path that keeps it within 5 degrees of our ecliptic while offering close encounters with multiple planets. This isn't just one lucky alignment, but a series of precise rendezvous that would be virtually impossible by chance alone. The narrow window for achieving these flybys underscores the anomaly. A cosmic traveler hitting the mark with such accuracy suggests intent, not accident. If this is a natural object, it's rewriting the odds of celestial mechanics. If artificial, it's a beacon of intelligence, a message from the stars that we're only beginning to decipher. The clock is ticking, and the urgency is palpable. On October 21st, Superior Conjunction looms. Earth, the Sun, and 3I/ATLAS will align perfectly, plunging the object into the Sun's brilliant glare and rendering ground-based observations nearly impossible. Hubble and Webb have been silent since August, their views overwhelmed by solar light. We're left with high-altitude observatories in deserts like the Atacama or Namibia, battling atmospheric distortion and the chaos of solar maximum, where frequent flares and coronal mass ejections (CMES) create a turbulent electromagnetic environment. On September 19th, a CME slammed 3I/ATLAS from September 24th to 25th. Normal comets would lose tails, sputter cores. This object, unshaken, its anti-tail steady, its glow unwavering, a resilience that defies expectation. Perihelion on October 29th will see 3I/ATLAS at its closest to the Sun. Bathed in intense heat, its secrets potentially transforming in ways we can't witness. Hidden behind the solar veil, whatever processes unfold, whether natural sublimation or engineered activity, will occur out of sight, adding an unbearable layer of mystery. The November launch of the Jupiter Icy Moons Explorer JUICE mission offers a fleeting chance, its spectrometers poised to probe 3I/ATLAS from a distant perch as it swings outward. But the window is narrow. The object's velocity compresses evolutionary changes into days, even hours. Missing a single observation could mean losing critical data on how this enigma behaves under solar stress. Solar maximum complicates everything. Flares could mask emissions, amplify anomalies, or trigger new behaviors we're unprepared to interpret. Every day brings us closer to the moment when 3I/ATLAS slips from view, its truths locked away until it emerges months later, forever altered by its solar encounter. The compressed timeline is a call to action for astronomers worldwide. Ground-based observations face mounting challenges. Atmospheric scattering distorts faint light, and weather conditions at even the best sites can ruin a night's work. The object's extreme speed, 60 kilometers per second, means changes that might unfold over months in a typical comet happen in weeks or days here. The September brightness surge, the anti-tail's persistence, the chemical shifts all suggest a dynamic system evolving faster than we can track. As solar maximum peaks, with auroras painting Earth's skies and electromagnetic chaos rippling through the inner solar system, 3I/ATLAS navigates the storm with an almost eerie calm, its behavior hinting at a robustness that feels engineered. The race is on to capture every photon, every spectrum before the sun's glare steals our view, leaving us to wonder what we missed in the cosmic dark. Amid this cosmic drama, NASA's Near-Earth Object Observations program stands as humanity's vigilant guardian. Funded through initiatives like YORPD, it powers systems like ATLAS, the Zwicky Transient Facility, and the upcoming NEO Surveyor, set to launch in September 2027 aboard a Falcon 9. As of September 2025, the program has cataloged 38,000 near-Earth objects, NEOs, achieving 43% of its goal to map all hazards larger than 140 meters. NEO Surveyor, an infrared sentinel, will hunt 2/3 of these threats by 2032, pinpointing sizes, compositions, and orbits to assess risks. The 2022 DART mission proved we can nudge asteroids off course, a blueprint for planetary defense. But 3I/ATLAS, it's no immediate threat, passing no closer than 1.8 astronomical units. Yet it's a teacher, a cosmic envoy reminding us that danger and wonder can arrive from beyond our solar system. This interstellar visitor underscores the urgency of NASA's mission. Interstellar objects like Oumuamua and Borisov were small, fleeting. 3I/ATLAS is a giant. Its 5+ kilometer nucleus and 33 billion ton mass, a stark reminder of what might lurk undetected. NEO Surveyor's infrared gaze will revolutionize our catalog, spotting objects too faint for optical scopes, refining orbits to predict potential impacts decades in advance. The program's global network, telescopes in Hawaii, Chile, South Africa, coordinates with amateurs and professionals alike, building a web of eyes that caught 3I/ATLAS in the first place. Its anomalies challenge our models, pushing us to refine detection algorithms and prepare for the next visitor. Could such objects carry life's building blocks, panspermia seeds forged in distant stars? Or, as Loeb suggests, are they probes, scouting our system for reasons we can't yet grasp? NASA's work work isn't just defense. It's a quest to understand our place in the cosmic tapestry. The broader context of planetary defense adds weight to this moment. The discovery of 3I/ATLAS highlights gaps in our vigilance. Only 3 interstellar objects detected in history, yet statistical models suggest thousands pass through our solar system annually, unseen. The Vera C. Rubin Observatory, coming online in 2026, will flood us with data, potentially revealing fleets of such wanderers. Each one is a chance to learn, not just about threats, but about the universe's history, chemistry, and perhaps its inhabitants. 3I/ATLAS, with its size and strangeness, is a wake-up call. We must scale up, look farther, and prepare for surprises. NASA's efforts, from DART's kinetic nudge to NEO Surveyor's infrared sweep, are humanity's shield and telescope, peering into the unknown to protect and enlighten. This isn't just a story for astronomers in sterile control rooms or scientists poring over spectra. It's our story, a tale that binds every human who's ever looked up and wondered. Our ancestors saw comets as omens, fiery harbingers of fate etched across the heavens. Today we decode them as kin, stardust shaped by the same forces that birthed our world. 3I/ATLAS, whether rock or relic, bridges eons and stars, a reminder that we're all adrift in the same cosmic sea, connected by the elements forged in ancient stellar furnaces. Its green glow, its impossible tail, its unyielding mass, they expand our imagination, pushing us to ask, what else is out there? Are we alone, or are we being watched? Our system, a waypoint for travelers we can't yet comprehend. The universal appeal of 3I/ATLAS lies in its power to unite us. From UCLA's meteorite vaults, where you can hold a piece of the cosmos and feel its ancient weight, to the global network of amateurs tracking every arc-second of its path. This is a shared quest. Namibian astrophotographers capturing its emerald shimmer, professionals at Palomar analyzing its light curve. We're all eyes now. The green glow speaks of transformation, whether C2 or something stranger, hinting at chemistries that might birth worlds. The anti-tail defies entropy, a bold gesture against the universe's chaos. Its size? A monument to endurance, surviving a billion-year gauntlet to reach us. As solar maximum paints auroras and CMEs roil the system, 3I/ATLAS sails through, our proxy in the storm, carrying questions that resonate in every heart. Where did it come from? What does it mean? This moment transcends borders, disciplines, and beliefs. It's not about one nation or one scientist. It's about humanity's collective gaze upward. The Vera C. Rubin Observatory, set to scan the skies in 2026, promises to reveal more interstellar visitors, each a new chapter in our cosmic story. 3I/ATLAS is a mirror reflecting our own ambitions. Are we too probes in the dark, sending signals like Voyager's golden record, hoping to be heard? Its anomalies, orbital precision, chemical oddities, optical quirks challenge us to rethink our place in the universe. Natural or artificial, it's a call to curiosity, a reminder that the unknown is not to be feared, but embraced. A spark to ignite our drive to explore, to question, to dream. You are part of this story, and your role is vital. On October 28th to 31st, 3I/ATLAS will shine at magnitude +1, bright enough for binoculars under dark skies. Step outside, point your lenses toward the constellation of Scorpius, and witness history. Share what you see. Snap a photo, sketch the glow, tell your friends. Spark wonder in your community, whether it's a backyard stargazing party or a post on social media. This isn't just for experts, it's for every soul who's ever marveled at the night. Like this story, if it stirs your curiosity, comment your thoughts. Is 3I/ATLAS a comet forged in chaos or a crafted relic from a distant mind? Subscribe to stay in the loop. We're on this cosmic ride together, tracking every twist until it fades from view. Your engagement fuels the quest. Share a theory. Could its anti-tail be a propulsion artifact or a natural quirk we've yet to understand? Debate with friends. Is its orbit a cosmic fluke or a deliberate survey of our worlds? Every like, every comment, every shared moment builds a global conversation, echoing the collaborative spirit of science itself. From the Atacama's telescopes to your backyard, we're all astronomers now, united by a single question. What is 3I/ATLAS? As it races toward perihelion, hidden by the sun, its legacy will linger, not just in data, but in the wonder it ignites. Look up, connect, and keep asking. The stars are waiting for your voice.